All right, hello and welcome to the channel. My name is Brian De Leon Vargas, and today we're going to be solving a geometry problem. Let's take a look. Today's problem is a triangle and a square. So, the problem says, find the area of a circle that contains an equilateral triangle with a side length of n. The 3 points of the triangle are inscribed into the circle. All right, with these geometry problems, it's always best to try to visualize when possible. Over here, we have a couple of simple shapes. We have a circle. I'm gonna write that green. And then we have an equilateral triangle. I'm gonna do that red. So equilateral triangle is just triangle where all the sides are the same length. So let's start off by drawing the circle. Probably easy. That's an oval. We'll try again. There we go. All right, we have a circle. And now let's draw an equilateral triangle. I'll try my best. We'll see if it can register. Yeah, there we go. Nice. It's not perfect, but we get the idea. Uh, and then we know that the sides of the triangle are a length of n. So this is n, this is length n, and this is length n. Now, we have our problem. What are we solving for? Well, we're solving for the area of a circle. That's basically just this area over here. All right, now that we have our problem drawn out, we can start thinking about this problem, how we're going to solve it. Well, here's our diagram from earlier with an extra step. But how do we solve for the area of a circle? Well, we're going to use the equation area is equal to pi r squared. There we go. Now, we don't know this value r, it's unknown, but we do know that n is known. It's a variable that we're using here, whether that be 1, 1,000, a million, we'll just leave it as n, that's fine. How can we solve for r using what we know about this equilateral triangle? Well, let's take a moment to think about the properties of an equilateral triangle. Here's our triangle, and here's some fun things about a triangle. And then this line R. This line R is basically, since it's the radius of the circle, it's the point from the middle to this point here. Since this is an equilateral triangle, this distance R is the same as this distance and is the same as this distance. All these points touch our circle. So we know that this point where R starts from is the center of the triangle. And then since we have this center of the triangle, we actually know some special properties about some angles in this triangle. So we can start off by trying to find a 90-degree angle. Right now, we don't have any 90-degree angles. Equilateral triangles have internal angles of 60 degrees on all 3 points. This over here is also 60. But how can we make a 90-degree angle? Well, we can start off from the center of the triangle and bisect one of the sides. So we'll split it in half. We know that the sides are all of length n, and then if we bisect it, that's just half. So I'm going to go ahead and go here, and we know that this length over here is n over 2. Now we recently also just said that these angles, I'm going to call them theta, they are equal to 60 degrees. I'm going to just call this theta over 2 because this angle here is also bisected by this line right here. That means our angle here is theta over 2. And we know that theta is equal to 60 degrees. All right, let's continue. Now that we know these properties, solving this solving for r is simply a matter of using trigonometry. We have our right 90-degree angle here. It's a bisect. It's 90 degrees, perfect, perpendicular to each other. So we're just going to take out this part of the equation, put it over here, and we're going to use trig to help us out. Now, we did say that theta over here is equal to 60 degrees, and then that's also equal to, I'm going to use radians because I feel like we're used to, there we go, the unit circle, so pi over 3. So here, theta is equal to pi over 3. Here, theta is equal to pi over 2. I'm going to rewrite this. I'm going to rewrite this as, let's use red, 1 over 2 times theta, which is equal to 1 over 2 times pi over 3, which is equal to pi over 6. All right, we know our angle, and we know two sides. What's two sides? We have one that's known, n over 2, and one that's unknown, but we have variables for them. What we're trying to solve for here is this r, this length r. So let's try to write out an equation. Sine, cosine, tangent, SOHCAHTOA. This is the adjacent angle, and this is the hypotenuse. So we're going to use cosine. The cosine of pi over 6, we're going to do adjacent over hypotenuse, which is n over 2 all over r. And then we're going to solve for r. So let's go ahead and switch out cosine pi over 6 and r. So r is equal to n over 2 divided by, I'm going to just put cosine pi over 6. If we remember back to the unit circle, cosine pi over 6, what does that calculate to? Let's see, n over 2 all over, all right, let's do some quick math here. Yes, perfect. That is equal to square root of 3 over 2. Now let's go ahead and take this division, and we're just going to flip it, flip the denominator, flip them around, and then multiply. So that's n over 2 times n over 2 times 2 over square root of 3. The 2's cancel. That means that we get n over root 3, and then we're going to standardize that to root 3n. Sorry, I'm going to do n root 3 over 3. All right. So we've solved for r. This is our r value. R is equal to n root 3 over 3. Amazing. Now we're solving for the area of a circle. We know that area is equal to pi r squared, and we know that r is equal to n root 3 over 3. So this is just simple arithmetic over here. Area is equal to pi, and then put this in parentheses, n root 3 over 2, or over 3 to the second, and then that's equal to pi. I'm going to apply this term to each of the terms. So that is n squared times 3. The square root cancels out, and then we have 3 squared. Luckily, we have 3 over 3. That's why I didn't write it as 9. We'll just cancel this out. So cancel out this 3 minus 1. This is 3 to the 1, which is just 3. So our answer is going to be pi over 3n squared. Yeah. Here's our answer to our problem. What's the area of this circle? If there's an equilateral triangle inscribed into it with side length n? Well, we just solve for the radius using trig, right angles, cosine. We used this angle over here, and that gives us this answer. Nice. All right, that's the end of this problem. Thank you guys for watching. If you guys liked this video, please let me know. Like the video, comment, give me any other problems that you think would be interesting to watch me solve. So thank you guys for your time. Peace out.